All right, we're going to look at differentials. So first thing we need to look at is just what different increments mean. So we have some function and we have some values here. We can find the actual change in these values. So x1 is just some point. x2 is just another point. And we could rewrite this second point as the first one plus a change. That triangle, that just means change. And then we have some y value here. I could say y1, but if I use f of x1, that tells me the function value at that point. And the second one, same reason. I could say y2, but I need the function value at that second point. The change in x, we can just subtract the two values. The change in y, again, we could just subtract the two values. So change in y, you would just y minus y. So take the second one, so x2, minus the first one to find that change. And x2, remember, is really the first one plus some change. So let's look at some and throw some numbers into things. So given the function y equals f of x equals x squared plus 1, find the change in x, change in y, and then the change in y over the change in x. So that's just the slope between those 2 points. For x1 being 2 and x2 being 3. So I'm going to draw a little visual here. So I have a function. I have 2. I have 3. And I want to find the change in x and the change in y. So the change in x is this distance here from 2 to 3. So 3 minus 2, that's just 1. Now I want to find the change in y. So I need to know the y values. So I know here that it starts with 2. And I can substitute in my function. So 2 squared is 4 plus 1 is 5. This other point I know is 3. So I can substitute in f of 3. So we would get 3 squared plus 1. So 3 squared plus 1, 9 plus 1, that's 10. Now I can find the difference in the y's. So that's 10 minus 5. That gives me 5. And then I can do my change in y over my change in x. That's just going to be the slope between those 2 points. So change in y was 5. Change in x is 1. All right. Part B says find f of x1 plus some change in x minus f of x1 all over the change in x. And I'll do it in another color. So x1 is 1. Our change in x is 2. So f of x1 and my change minus f of x1 all over my change in x. So really, that's f of 3 minus f of 1 all over 2. F of 3 I happened to already find. That was 10. F of 1 I'll have to find. Gives me 2 all over 2. So I get 8 over 2, which is just 4. All right, now differentials. So if a function y equals f of x defines a differential function. Then the differential piece, so dy or df, is defined as the derivative. So derivative of x and dx, where dx is the same thing as the change in x. And dy, let's think of derivative. So the derivative we say is dy over dx is the derivative. Well, if I want just dy, I could just multiply both sides by dx. So dy is just f of x times dx. Okay? So let's look at approximations. So I found, in the first part, I found my actual change in x and my actual change in y. Now the derivative is like an approximation. So the change in y over the change in x is approximately the derivative of the function. So I can take change in y, change in x, so I should say approximately. And if I want to find just my actual change in y, I can multiply both sides by that change in x. But then we just said on the other side that dy is the derivative times dx. Remember, the change in x is the same thing as dx. So really, I could say that the change in y is approximately dy. So let's look at a visual. And I might have to do two different little triangles here. So we have this blue function here, and we have 2 points. I can find my actual change in x, or this change in x, and then I can find my actual change in y. Or if I use this first point and find the tangent line, so that's the derivative at a point, I could approximate the value of that second one, right? Because as that change in x gets smaller and smaller and smaller, it gets closer and closer to the actual value. So this distance here now is dy. This is my approximate change. And then notice my change in x did not change. So that's why the change in x is the same thing as dx. Right? See if we can throw some numbers into it to make it make a little bit more sense. So find dy for each function. So dy is just the derivative times dx. So I'm just going to find the derivative here. Dy equals the derivative. Derivative of 30 is 0. Derivative of 12x squared is 24x. And the derivative of negative x cubed is negative 3x squared. And then I just need to multiply it by the change in x, which we don't have, so I'm just going to leave it as dx. Let's try this function. We don't have a product rule for our derivatives yet, so I need to distribute that x squared. So that's x squared minus x cubed over 9. Now I can find the derivative. So dy, the derivative, is going to be 2x minus 3/9 x squared, all times dx. And then the only thing I'm going to do is clean up that fraction there because I can reduce that. So that's 2x minus 1/3 x squared dx. Okay. Let's look at if we were given some more numbers. This is just our general stuff for this general functions here. Let's say we have a function. We have an x1 value, and we have a change in x value, or a dx. So let's work this out. So we want to find dy, which is that approximation, and then the actual change in y. So this is what I need. Let's find the approximation first. Let's find dy. So remember, dy is the derivative times dx. Let's find the derivative first. So that's 2x minus 3 times dx. We have an x value, so I'm going to substitute that in. And I have a dx value. So let's see, that'd be 10 minus 3, which is 7, times 0.2, which gives me 1.4. So cool. I have an approximation. Let's find the actual change in y. So the actual change in y, remember from way back on the very first page, change in y is that f of x1 plus my change in x minus f of x1. So my actual change in y is 5 plus my change, so 0.2, minus f of 5. So f of 5 plus 2 minus f of 5. So I need to do some side work here. And say I need to find f of 5.2. So that's 5.2 squared minus 3 times 5.2 plus 2. And I need f of 5. So that's 5 squared minus 3 times 5 plus 2. And if I put these in the calculator, let's see. We have 13.44 and 12. So the difference between them, so 13.44 minus 12 is 1.44. And look how similar those are. So that's why we can take a derivative, because it's approximately the same as the actual change. And finding the derivative is usually a little bit faster than having to find all these function values so that I can subtract and all this stuff. Okay, let's do for some more stuff. So for this function, we're going to find the actual change in y. We're going to find the approximate change in y for the given values we have. And let's do all of that first. So let's find the actual change in y. So I have my x value, and I have 3 different changes in x. Let's do the smallest change. So my actual change in y, I need to find the function value of negative 0.5 plus that change minus the function value at my original point. So let's see. I need to do negative 0.5 squared plus 2 times negative 0.5 plus 1 minus the function value at negative 0.5. So negative 0.5 squared plus 2 times 0.5 plus 3. And I definitely meant to put plus 3 here. And now let's get those actual values. So this is going to give me 2.36. And then this is going to give me 2.25 for an actual change of 0.11. So now I want to find the approximate change, right? So dy is the approximate change, and that's the derivative times dx. So the derivative is 2x plus 2 times dx. My x value is negative 0.5, and my dx value is 0.1. So let's see, that's first one's going to give me 0.1. Part B says to graph them. And you can plot all the points if you want to, but I don't think we need to see what it looks like. And part C says to compare. So compare your actual and your approximate. So okay, my actual is 0.11 and my approximate is 0.1. You see how much less steps doing the differential was than to do the actual? And I can do it all again for the next one. So I'll do it in a different color. So we'll do it for 0.02. So my actual change is the function value plus the change minus the function value. So you can substitute it in. And I get 2.49 minus 2.25 for an actual change of 0.24. Let's find my approximate. So I already have it from my first step, so 2x plus 2 times dx. Well, dx is now 0.2. My x is still the same, negative 0.5. So when I plug this one in, I get 0.2. And look at that. Let's do the third one. Do it in yet another color. So the actual change is my change in my y's. I know that one is 2.25. It's the same. And then this one, when I plug it in, I get 2.64. So when I subtract those, my actual change is 0.39. Let's get my approximate. 2x plus 2 times my new change of 0.3. So let's see, 2 times negative 0.5 times 0.3. And that gives me 0.39. So this one actually was close, like closer. So that's kind of cool. Let's look at some more. Let's look at some like applications. A cube with 10-inch sides is covered with a coat of fiberglass that is 0.2 inches thick. Use differentials to estimate the volume of the fiberglass shell. Do my best to draw a cube here. And then we have 10-inch sides. All right. So volume of a cube is all the sides multiplied. Length times width. Length times width times height. Well, it's a cube, so all of them are the same. So I could just say sides cubed. But we have a fiberglass coating. So I'm going to look at one face of the cube. It has a 0.2 thickness everywhere. So I really want my, I need to figure out what my change in my side value is. So my new side value is the side, right? And my change, I'm changing in all directions, but because it's a cube, it's going to be the same all around. So my change is actually 0.4. Change in x is 0.4. So I could really say my change in s for side is 0.4. So differentials, let's find dv. So dv is the derivative, so 3s squared times the change in s. So, okay, our side lengths are 10, and I just found my change to be 0.4. That's going to give me 120. Let's look at a sphere. So a sphere, the radius of 5 centimeters is coated with ice, 0.1 centimeters thick. Use differentials to estimate the volume. So okay, we have our volume formula. Volume is 4/3 pi r cubed. We know our radius is 5. I just need my change. My change is at 0.1. So I'm going to find the derivative, dv. 4/3 pi is a like coefficient. So I can bring that out, and then I can do the derivative of just the r cubed, which is 3r squared. And I'll clean this up in a minute, and then we will have times dr. 3 divided by 3 will just cancel out, so I actually have 4 pi r squared times dr, which is 4 pi. We have a radius of 5, and my change is 0.1. So then we get 31.4. Right. Revenue and profit. A company manufactures and sells X TVs per month. If the cost and revenue equations are as follows, what will the approximate changes in revenue and profit be if the production is increased from 1,500 to 1,510 and 4,500 to 4,510? All right. So let's do revenue first. So I need to find derivative and times it by dx. I guess we could say dr for derivative of the revenue. 200 minus 2x over 30 times the change in x. So we would have 200 times, or minus x over 15 times the change. Well, for this first one, our change was 10. So I can substitute in the 1,500, and our change is 10. And I get 1,000. And then I can do it for the 4,500. So, same thing. I can use that same function. So, 200 minus 4,500 over 15 times the change, which was 10. And this time I get negative 1,000. Now let's do it all for profit. So profit is actually revenue minus cost. Oops. So let's see. That's going to be revenue. So 200x minus x squared over 30 minus my cost function. So 72,000 plus 60x. But I'm really subtracting everything over. So I get 200x minus all that, minus 72,000 minus 60x. So let's finish out what this would be. You'd have negative x squared over 30. 200 minus 60, that's 140 minus 72,000. So that's my profit. Now I need to find my derivative, or my differential, so we'll call it derivative of the profit. And that's going to give me, let's see, negative x over 15 plus 140 times the change in x. And I can do both the 1,500. So negative 1,500 over 15 plus 140 times the change, which is still 10. I'm going to write the other one down so I can just type them in at the same time. So 4,500 over 15 plus 140 times that change in 10. And I'm going to put these in the calculator. So negative 1,500 over 15 plus 140 times 10 gives me 400. And then negative 4,500 divided by 15 plus 140 times 10 is negative 1,600. And there we have it. So if you have any questions, let me know.